Hello everyone, welcome to my new programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is minimum replacements to sort the array. So you are given a zero indexed array nums. In one operation, you can replace any element of the array with two elements which sum to that element. For example, consider the nums array to be 5, 6, 7. In order, in one operation, we can replace the number at the first position, which is 6, with 2 and 4, since 2 and 4 sum up to 6, and convert this nums array into 5, 2, 4, 7. So return the minimum number of the operations you can make you number of operations to make the array in non-decreasing order or ascending order. Let's discuss our approach. It's mentioned that you have to make the array in the non-descending order. So and also you have to minimize the number of operations. So it is very intuitive to think that at least we should make all the elements equal. As equal as possible. What I mean by as equal as possible. For example, let's consider two numbers, 6 and other one is 3. Now let's say this is the number given to you. What you can do is at least you should make this 6 equal to 3. You need not have to make 6 lesser than 3. Why lesser than 3? If we go on making 6 lesser than 3, then we will be increasing the number of operations. And they will not provide any optimal solution since we have to make only elements in non-decreasing order. So it means that uh, elements can be equal also as long as they are non-decreasing order. So this is also a non-decreasing order. This is also a non-decreasing order. Both of them are non-decreasing order, so elements can be equal. So we will not waste our operations making the previous element smaller than the next element, current element. So, and it is also, this is observation number 1. Now we will make another observation. How many times you have to perform this operation? On 6, you have to perform this operation one time, which is nothing but if we go on calculating mathematically, it is previous number. This is the current number. This number divided by current number minus 1. Since when we will be getting 3, only one operation. Though if you divide 6 by 3, you will get 2 as quotient, but that's not the number of operations. It is 1 minus to this number. So And there can be another case, let's say instead of 6 there was 7. So here you have to adjust your calculations a little bit. What I mean to say is, let's say firstly you divide them something like that. Since one number will be having one extra, uh, because 7 modulo 3 is 1. So this will be the uh, this will be the extra value that one of them will be having. So you can take this into account. And what you can do is, if the previous number is not divisible by the current number, then you will let's call this variable as number of operations or number of times you have to perform the operations. So if the previous number is not divisible, then you will simply increase the number of times. And also in this particular case, it will be 7 will be broken up into these numbers so that we are having non-decreasing order. And what will be the next previous number? So next previous number will not be 3, it will be a lesser number. So lesser number will be this one. So what will be the this is the case where the previous number changes. Let me quickly change the color. Previous number does not remain same. Why we are changing the previous number? It will or not always be the case that this nums array will be of size 2. It can be of any size. It can be 1, 2, 5, 6, 3. And why we will be starting at from the very last position? That will be the third observation. So what will be the previous number here? Previous number will be, you will be increasing number of times by 1. Previous number will be your current number. Uh, uh, in case of the array, we will be starting from here, and let's define, let's change the terminologies a bit. We will be calling this as a previous number now. Since it was of length 2 only, so previous and current denotations were not mattering much. And let's call this as a current number. So it will be this current number 6 divided by number of times the operations have been carried out. It is to be noted that firstly you will increment the number of times the operations need to be carried out. Then you will divide the current number by the number of times. Why we are doing so? Consider this scenario 1, 2, 3, 4, 5. Now you will be I will be explaining you in the another observation why we are starting from the very last. This will be your previous, and you will start from this particular number. This will be your current. So in this case, the number of times will be the number of times operations need to be carried out. 4 divided by 5, it will be 0. We will take the integer value, or you can say the floor value. So, so if it is 0, then how you will be, and this is also the case that previous number is not divisible, uh, current number is not divisible by previous number. Since it will give us remainder 4. So let's say you do 4 divided by number of operations. Number of operations for your number of times is 0. So it will not be a valid operation dividing by 0. So instead of dividing by 0, you will first increase your number of times, which is anyways you will be increasing. But when you will increase matters, you will increase before calculating the previous number. So I hope this is clear to you why we are increasing this before calculating the previous number. And in this fashion, you will continue iterating your nums array in right to left direction. Now, third observation, why we are choosing right to left direction. Let's say something like this was given to you. Now, let's say you are moving from left to right. You see that 6 is greater than its previous number. So you did something like this. Now you will see that this 1 is now smaller than the previous ones, previous numbers. So you will have to change all of them. So you will not be able to do this in a single traversal. And your time complexity will be not linear. So this is the reason we are traversing from right to left. If you go on traversing from right to left, you will immediately know that how many number of operations you have to apply, and it will be something like this. I hope you are able to understand why we have opted for such an approach. Uh, so these will be the 3 observations. According to them, we will be forming our greedy solution. We are greedily making only numbers as much as equal to each other. We are greedily adjacent numbers as much as equal to one another. For example, 7 and 3, these two, all the numbers we will be forming after performing the operations will not be equal, since 7 is not divisible by 3. But it be the case, would have that your 6 will be there instead of 7, then the numbers would have been 333, and all of them would have been equal. So in this case, equal numbers would have been generated, but in this case, equal numbers will not be generated. It will be something like this. So we are making the numbers, two adjacent numbers, as equal as possible. So these are equal, but this is not equal. We cannot do anything about it. So this is what I mean by making two adjacent numbers as equal as possible. So that's the solution. Now let's have a look at the implementation of the solution. And if you check the number of constraints of the problem, so since we are doing a single traversal on the nums array, then the number of operations will be at max 10 raised to power 5, which is nothing but the size of the nums array. And these are lesser than the 10 raised to power 8 operations. Basically, this is a limit that if you the number of operations of your program, let me quickly change that color. Number of operations of your program exceeds this number of operation or becomes equal to it, then you may get a TLE. Otherwise, your solution will be accepted. So those of you who are not familiar with this concept, I will be providing a link of an article describing how the time complexity of accepted solution varies according to input size. So you can explore this article, and then you will be able to understand why we are taking this as the limit. So let's quickly move to the implementation part of the problem. We will be traversing the nums array from right to left. In order to achieve linear time complexity without much trouble. Can also achieve linear time complexity here also. How you will be achieving? Let's say there was this array given to you. Let's take the example that we previously took. Let's say this was given to you. You can easily check what is the minimum value in the array. And at least all of the elements in the array have to be equal to that minimum value. So they can be greater. I don't think it will be feasible. So I think this is the better option to go from right to left. That's why we are taking this particular direction, traversing the array in right to left order. And the number of times that you will be, the number of times that you will be carrying out the operation current number, divided by this number. So in case the previous number does not fully divide the current number, in case the does not fully divide the current number, the operation times by 1, and then we will change our previous number. Since previous number will no longer be the same value, it will be decreasing. That's the case. And operation number of times will be nothing but total number of operations will be increased by operation number of times minus 1, because you can see here also, let's say 3 and 6 were given to you. If this is your current number, basically if a two size array is given to you, you can uh, decide which one you will call current or previous. It does not matter really. Let's say I call this current number and this is the previous number. So the number of times you have to carry the operations is previous number divided by current number minus 1. So it will be 6 divided by 3 minus 1, which will be 1. So I hope you are able to understand, but if the length of the array is more than 2, then you have to take proper denotions of these current and previous numbers. So this will be our previous, since we are traversing from right to left in this direction, and this will be our current. So that's the case, and at last you will be returning the number of operations. This is the approach to solve the problem, and it was a not very much hard problem if you get the mathematics behind it. Thank you for watching. If you are still having any doubts, please feel free to ask them in the comment section. Thanks.